Today we are going to be focusing on AWS Compute resources which can perform compute related operations on the AWS cloud. If you are not yet subscribed, hit the subscribe button right away and let's get started with knowing these compute services. Compute is one of the flagship areas which AWS sells to clients, and by that, different clients have the various ways which they want to carry out compute operations on the AWS cloud. Now in this video, I'm going to be walking you through the compute resources which AWS has on the AWS console. So we're going to dive into the console and you just have a feel of what some of these compute resources are. These compute resources are categorized into the AWS Elastic Compute Cloud Service, the AWS EC2, which is one of the most widely used AWS service that has a lot to do with compute at the level of pay-as-you-go model. Compute basically is one of the most on-demand compute resource which AWS offers, and when you're looking at AWS compute resource, you want to look at some key areas around auto-scaling or scaling compute resources to meet your traffic requirements. You equally want to look at how to manage traffic into your compute resource by auto-scaling. You want to also look at how to manage traffic into your particular infrastructure by load balancing. AWS also has the AWS Fargate. Now, Fargate is AWS way of running compute serverlessly, because some companies actually have servers and they spend a lot managing servers, to configure these servers. If you don't want to have the stress to walk through configuration and management of these servers, you can pass on all the responsibilities to AWS and they will take care of all these server management and updates and security and all of that, and that is done by the AWS Fargate service. So Fargate is serverless, management is done by AWS, and you just provision your resources on the Fargate Compute Cloud by AWS. Now the next category of AWS compute resource which we have is the AWS Lambda. Now AWS Lambda is a service where you can run compute. Basically, developers don't necessarily need to provision an EC2 instance or a particular infrastructure requirement to run their codes. So with AWS Lambda, you pay only for the time which your code is being run. You want to check out AWS Fargate, AWS Lambda for serverless processing of application code. Now the next AWS compute service which you have is the AWS Elastic Container Service. Elastic Container Service is the management of containerized applications on AWS, and you can manage your containerized applications on the AWS Elastic Container Service. Now this Elastic Container Service has the EC2 type, like that which is based on the Elastic Compute Cloud, and we equally have the Fargate type, that which is based on the AWS Fargate. So as far as Elastic Container Service is concerned, you can manage containerized applications with the EC2 type Elastic Container Service or with the Fargate based Elastic Container Service. Now the next category of service which you can use for your compute is the Elastic Beanstalk. Elastic Beanstalk also helps you to manage your applications, especially mobile applications on AWS with the Elastic Beanstalk. And equally, we have the Elastic Kubernetes Service, the EKS. Well, Elastic Kubernetes Service is one of AWS major container orchestration services. The container orchestration service, Elastic Kubernetes Service, enables you to perform orchestration of your containers. So if you want to bring Kubernetes to the AWS cloud, you're thinking about AWS Kubernetes Service, the EKS. That's just a summary of the AWS compute services which I recommend you to know if you are a starter or if you want to ace yourself for your interview. So play around these services and let's dive right into the console so I can give you a feel of all these services. Right away, we are going to start with the Elastic Compute Cloud Service, the EC2 service by AWS. And here we are on the AWS console. The AWS Elastic Compute Cloud has various key things which you must know. We have the EC2 instances. Now EC2 instances basically refer to the way which you can create compute resources, and there are various instance types which you can of course do your personal research and know about them from the AWS documentation. I shared a link to how you can get AWS documentation, so you want to check our previous video on how to get AWS free resources. Now on the AWS Compute Cloud, we can have AWS EC2 instances. Basically, these are the ways in which you can have your compute resources. You can actually launch an instance. Basically, you can create an instance or you can migrate a server to AWS cloud. Now there are various instance types which AWS has, and once you come to the AWS Compute portal, you can know there are various AWS instance types based on the particular requirement which your application has. Then equally, as far as AWS, so there are various instance types that AWS has that match different specifications based on maybe the number of virtual CPUs, the architecture, the memory, the storage type, or the network performance. These are some criteria which AWS uses to classify their various storage instances or their various instance types. And then equally, we can have instance that's already been been launched before, or what they call launch templates, which are maybe pre-configured instances that already have some kind of dependencies and applications already running on them. And then we have spot instances, reserve instances, dedicated hosts, scheduled instances, and capacity reservation. So these are the various type of instances which you can have on the AWS console. We equally have AWS images, or Amazon Machine Images, AMIs, which basically are the operating systems which you use to launch your EC2 instances. Now there are different types of Amazon Machine Images. We can have images based on the Linux operating system, based on the Ubuntu, based on the CentOS, based on Windows, based on Red Hat, based on Mac OS. All of these gives you the ability to launch your operating system or all your EC2 instance based on a particular operating system type. So that's why we have the AWS Amazon Machine Image. You can equally have the Amazon Machine Image catalog of resources or of AMIs that you've already created. Maybe those you've created by yourself, like this, for example, are AWS AMIs that are already available for you to use on the go. We have Amazon Linux based on the Linux family. Like I said, you can have instances based on Linux, Unix, on Windows, based on the architecture. You can have instances which you've created. You can have instances on the AWS marketplace. You can have community instances. So these are all the categories, or basically the catalog of AWS instances that are available. In the Compute Cloud Console, you want to also take note of the Elastic Block Store, EBS, which is one of the key characteristics of EC2. We have EBS volumes, where these are actually the storage types. You maybe want to have a compute capacity of 20 gigabyte of storage, or 50 gigabyte, or 100 gigabyte, or whatever, 1 terabyte. You actually do that by configuring the AWS EC2 volume. So you can have different volumes of different types. You can actually create a volume to meet your capacity requirements. If you want to actually move this volume from one AWS region to the other, you can create snapshots. Snapshots is one of the ways which you can keep track of your current volume data, or if you want to migrate this particular EBS volume to another AWS region where you can launch a new EC2 instance from, you want to do that by using snapshots. And well, the lifecycle manager equally helps you to actually automate the creation, the retention, the copy and deletion of your snapshots and your AMIs. Now, snapshots is one of the security postures which you can use to make sure that your data in your EC2 instances are always safe and secure without you losing track of data. Now, as far as security on compute is concerned, we have the AWS security groups. Of course, EC2 instances, security groups are like firewalls, kind of preventing unauthorized access to your AWS EC2 instance. So you want to configure security groups to help you manage inbound and outbound traffic, like traffic that gets into your instance and traffic that leaves your EC2 instance. So you do that by configuring your security groups. You can actually create a security group. You can add security group rules, which traffic or which IP address you want to enter into your EC2 instance, or which IP address you don't want to enter into your EC2 instance. So you do that by your security groups. Then equally, we have the Elastic IPs. Like if you want to have a fixed IP address for your EC2 instance, you can get that with the use of an Elastic IP. Now, Elastic IP, mind you, are services that are costly. So once you have an Elastic IP, be very careful, because it's going to cost you if your account is not actually a paid account. Then we equally have placement groups, the way you want to group your EC2 instances. You equally want to take note of a key pairs, because key pairs is one of the ways which you can use to log into your EC2 instance for configuration, maybe by SSH, like secure shell, a secure way of getting into your EC2 instance. You can do that by using key pairs. So you want to check that out. Then equally, as far as EC2 is concerned, you want to check out their load balancing. Load balancing, like I said, is the way which you manage traffic that comes into your set of instances or out of your EC2 instances. So that is done by the EC2 load balancing. And for you to set up a load balancing architecture or a load balancing technology for your EC2 instances, you must put the instances maybe in a group where they call target group. So configure a target group that consists of a fleet of EC2 instances that are then managed together, or that are then managed for you to effectively manage traffic distribution between those fleet of instances. The Elastic load balancers are actually what enable you to scale the capacity and automatically meet the requirements of your incoming traffic. If you're working on EC2, you equally want to manage the scaling of your already existing EC2 instances, or you want to manage how traffic will be coming to your EC2 instances. You can do that with the use of Elastic load balancers. Then equally, the last thing which is very important for you to master on the Elastic Compute Cloud is the auto scaling ability. Now, auto scaling configurations basically is the ability for you to manage the creation and deletion of EC2 instances in your particular account. So if you maybe have an application application that is requiring maybe a particular memory or a particular storage, and you want that limit to vary with your traffic, you can do that with the help of auto scaling. What amount of traffic or what number of EC2 instances do I want to add when the traffic is high on my network, and which number of EC2 instances do I want to reduce when the traffic is low on my network? So you want to make use of auto scaling functions. And for you to set up an auto scaling function, you need to first put a launch configuration where you configure the number of EC2 instances, the type of EC2 instances, your desired capacity, your minimum capacity, and your maximum capacity, and then you can use that to orchestrate or to manage your fleet of instances. So that is it for your AWS EC2 console. You want to make sure you check these services out, use your get a free tier account, practice around these services. The next service for compute is the AWS Lambda. Lambda helps you to run code without thinking about servers, but with Lambda we don't have to manage these servers, so pay only for the compute time which you use running your code. So there's no charge when your code is not running. With Lambda you can run your code virtually with any type of application or backend service with zero administration. It works by you maybe inserting your code based on your application code language. Maybe you have coded your application in .NET, in Go, in Java, in Node.js, in Python, in Ruby, or in any other custom runtime. So you want to use AWS Lambda to test your code. Basically, they use AWS Lambda mostly for maybe data analytics processing, where you want to run very rapid tests on your data, or if you want to configure maybe mobile backends to test how your applications will work, or maybe when there's only an API call on your application, you can think about using AWS Lambda. So take note of AWS Lambda as a service that it's actually serverless. If you want to mention about serverless service on AWS, first thing should come to your mind, we have the AWS Lambda service. We also have the Elastic Beanstalk. Elastic Beanstalk is an end-to-end web application management. So if you actually want to effectively manage your web applications hosted in any programming language, maybe be it Java, .NET, PHP, Node.js, Python, Ruby, Go, and any other Docker familiar servers, you can use the Elastic Beanstalk service. So with that, you can create an application, you deploy easily, and then you have your application easily running. The Elastic Beanstalk service is interoperable with AWS Lambda, with Lightsail, with Amplify, with API Runner, and with the Fargate service. So this is one of the major services you can use for your compute related task. Once you set up maybe an Elastic Beanstalk application, the next service which you want to think about as far as compute is concerned is the Elastic Container service. And like I said, it's a service for management of computerized applications and is fully managed container. So Amazon ECS is highly scalable and fast container managed service that makes it easy to run, to stop, and to manage containers in a cluster. For you to have the AWS ECS running, you must set up an ECS cluster. You can have different clusters in your ACS infrastructure. Basically, a cluster is a grouping of resources, grouping of your task definitions, grouping of your services, grouping of your task in an organized way. So even namespaces. So you want to group all your resources in an ECS cluster. Then namespaces basically is ways which you can use to kind of subcategorize these resources. Maybe if you are deploying an application that has maybe a home page, a about us page, a buy now page, or a blog page, you want to use namespaces to actually logically group these resources to avoid redundancy and to easily access what particular resource. So we equally have task definitions that define how your tasks actually are going to be running, the specifications of your containers and all of that. And then we equally have the ability for you to manage your repositories. I didn't mention Elastic Container Registry, ECR, but you want to make sure you check out ECR. ECR is one of the ways which you can use to store container images on the AWS cloud. So once you have a mastery of the ECR console, you create your images maybe with your code build. If you are running a DevOps pipeline, you might create those images with code build, and once the code build is complete, you may want to store the images in a repository system. The ECR service is interoperable with your ECS service which you are looking now, because once you maybe have an application that has already been created and you have the latest version of the image or the latest version of the application, you can then pull that image from your Elastic Container Registry and you deploy into your ECS cluster that will automate the creation of your ECS task or your ECS service that runs that application. So the ECS service actually has the service that is based on Fargate, so you can manage your applications in a serverless way with Fargate, or you can manage them with you actually managing the creation and the deletion of the servers with the use of EC2. So we have the ECS EC2 type cluster and the ECS Fargate type cluster, and each of them, like I said, deals with the area of, or the intricacy of both of them is around the level of management. If you want to have more management abilities, you want to use the EC2 Elastic Container Service, but if you want to have less management capabilities or less management overhead, you maybe want to use the AWS ECS Fargate service. Basically, I already have a cluster running, currently doing some application. I'm currently building a CI/CD pipeline, so I'm using the ECS service to deploy my application. You can use the ECS service, you can create a cluster. With the cluster, you create your namespaces, you create your task definitions, and you can set up other things. So this is just basically it about the Elastic Container Service. The last service which we are going to be looking at is the Elastic Kubernetes Service. Yes, Kubernetes is what is most needed in the industry. You can't be successful as a DevOps engineer if you don't know container orchestration with Kubernetes. And AWS native Kubernetes service is the Amazon Elastic Kubernetes Service, the AWS EKS. Now, the Elastic Kubernetes Service actually is a fully managed control plane service where you can create your Kubernetes clusters like you regularly do on the Kubernetes, where you create your Kubernetes cluster, you create your Kubernetes service, create your node groups. So basically, how does the EKS work? You basically set up your EKS cluster and then you deploy worker nodes on the EKS cluster. You connect to your Kubernetes by your Kubernetes controller, your kubectl, where you run Kubernetes declarative and imperative codes, manifest files, or whatever way which you've used to put up your Kubernetes architecture, and then you can then run your applications on the AWS Kubernetes service. Now, why you want to use Kubernetes is AWS native. It's kind of helps you to run your microservices on AWS cloud, so it may also help you to do batch processing. Now, as far as the AWS Kubernetes service is concerned, you can equally link it to your Elastic Container Registry for you to pull images to and from the AWS ECR. Once you create an Elastic Kubernetes cluster, you can then configure manage groups with the use of AWS node groups and nodes, which corresponds to the key functions or the key architecture. Because if you take your Kubernetes architecture, you want to look at your Kubernetes nodes, your control plane, your worker nodes. You equally want to look at your services, your pods. Very brief example: you create a cluster, you configure the cluster details, maybe the name of the cluster, basically the login. So for you to configure a cluster, there are some key things: how you want to manage your cluster, which Kubernetes version are you running on. You also want to configure your networking, which Kubernetes network, if maybe you've already created your network with CloudFormation or with Terraform, you can then use the network which you've already created. You can equally configure login for your Kubernetes cluster. You want to log maybe your Kubernetes logs in CloudWatch, or you want to export the logs from CloudWatch to maybe a login service like Prometheus, where you can set up your dashboards with Grafana. Then equally, we have the select add-ons. You can have some Kubernetes add-ons for your cluster which you can set up, and then you review and create. Once you create, you can then perform services like creating new namespaces, creating node groups, creating Kubernetes deployments, creating pods, and creating namespaces, secret maps, and config maps, and all of that. So that is a very brief about Elastic Kubernetes service. I hope this video you're able to understand the basics of some of the compute resources which AWS has, and like I mentioned, these are the key resources which I recommend you to know before you go in for your DevOps interview, or these are the services which you should be able to master and pitch during every DevOps interview or cloud computing interview which you have. So we want to continue watching this series, because in the next part of this series we will be introducing you to the storage services which AWS has. If you are not yet subscribed to the channel, hit the subscribe button and get subscribed, because more aspects of your DevOps journey will come from us in this channel. And equally, join our DevOps community with a link in the channel description or in the video description. And equally, if you want to book a one-on-one mentorship call with me, feel free to use the links in the channel description and in the YouTube, in this particular link video description, to get started. See you in our next video.